Hello everybody. Today we are going to discuss an important concept of the chapter of derivatives. The concept is chain rule. So far we have studied the standard formula of derivatives. Along with that we have also studied u plus v addition, u minus v subtraction, u into v product and u by v quotient rule, division rule. Now this concept of chain rule is often called as composite functions. It is also called as function of a function. Here I have written various standard formula which we have come across. Just let us recollect. Derivative of x raised to n is nx raised to n minus 1. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of sec x is sec x into tan x. Derivative of cosec x is minus cosec x into cot x. Derivative of cot x is minus cosec square x. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x log a. Derivative of log x is 1 upon x. Derivative of root x is 1 upon 2 root x. There are various ways in which we study composite functions or chain rule. Let us study chain rule today in the simplest possible way. First, any function which appears to be, which is similar to a standard form is known as chain rule function. Means it is not exactly the standard formula, but it appears like a standard formula. Now how will we come to know? Base in variable and constant in power. I repeat, base in variable and constant in power is x raised to n. Any trigonometric ratio with degree 1, any trigonometric ratio with degree 1 is a standard trigonometric function. Base is a constant e, a fixed constant. Power is a variable. It is like e raised to x. Base is any other positive constant a and power is a variable. It is a raised to x. Log of a function is log x and root of a function is root x. So when I interpret or write the question on the board, I want you to think which standard form it replicates. It looks like what? Base variable, power constant, x raised to n. Trigonometric ratios with power 1, standard trigonometric function. Base is e, power is a variable, e raised to x. Base is any positive constant a, power is a variable, a raised to x. Log of a function, log x, and root of a function, root x. The first example which I am writing on board is 5x plus 4 the whole raised to 7. Now, if I compare this with the standard forms which we have written, I see variable in the base and constant in the power. So for me, this is similar to x raised to n. Now I write a function sine 7x. When I see sine of 7x, the power of the trigonometric function sine is 1. So it is comparable to a standard trigonometric function. It is similar to sin x. Let me write tan cube x. The moment I write tan cube x, I can interpret it as tan x the whole cube. Now, students have a confusion. What should I compare this to? The ratio is tan x, but is the power of trigonometric ratio 1? No. So it cannot be compared to a standard trigonometric function. Any trigonometric ratio with a power other than 1, any other power, is compared to x raised to n. So this is similar to x raised to n. E raised to x square plus 5. Base is e, power is a variable, similar to e raised to x. 3 raised to 7x. Base is a positive number 3. Power is a variable, similar to a raised to x. log of 9x plus 4 log of a function, this is similar to log x, and ultimately root of 9x minus 3. Root of a function is root x. So this is similar to root x. Now, whenever you want to differentiate, find derivative of a chain rule function. Remember, step 1, compare the given question to you to its standard formula and differentiate it in the same manner. Means, जैसे x raised to n का डेरिवेटिव होगा, वैसे ही मुझे इसका डेरिवेटिव लिखना पड़ेगा. So the moment I compare this to x raised to n, then my derivative of x raised to n will be n x raised to n minus 1. I repeat, n x raised to n minus 1. So this derivative will be 7 into 5x plus 4 raised to 6. This is my first step. Here, if I observe, this is similar to sin x. What is the derivative of sin x, children? Derivative of sin x is cos x. So derivative of sin 7x will be cos of 7x. This is like x raised to n. So my initial derivative would be n x raised to n minus 1, which is 2. This is e raised to x. Derivative of e raised to x would be e raised to x. This is a raised to x. Derivative of a raised to x would be a raised to x log a. So far we have done nothing. We have just applied the standard formula which you have studied. Derivative of log x would be 1 upon x, and derivative of root x would be 1 upon 2 root x. So children, first step, if you come across a question which is a replica of a standard function, try and differentiate it in the same manner as you have been differentiating the standard function. Now, whenever you compare it to a standard function, you will see some function in place of x. Let us analyze. In the first question in place of x, I see 5x plus 4. In the second question in place of x, I see 7x. In the third question in place of x, I see tan x. In the fourth question in place of x, I see x squared plus 5. In the fifth question in place of x, I see 7x. In the sixth question in place of x, I see 9x plus 4. In the seventh question in place of x, I see 9x minus 3. So my step number 2 will be, you will redifferentiate that part which is given in place of x. You are continuing your differentiation. Therefore, it is known as chain rule. So the moment I saw 5x plus 4 in place of x, I would redifferentiate that part. Here I would redifferentiate 7x. Here I would redifferentiate tan x. Here I would redifferentiate x squared plus 5. Here I would redifferentiate 7x. Here I would redifferentiate 9x plus 4. Here I would redifferentiate 9x minus 3. Now children, this was my second step. First I compared it to the standard formula, differentiated in the same manner. Then I redifferentiate that part which is given in place of x. When you redifferentiate the part which is given in place of x, ask yourself one question. Now the derivative which I am finding, is it a standard function or a chain rule function? If you can apply the formula directly, it is a standard function. If you cannot apply the formula directly, it is still a chain rule function. I know the derivative of 4 is 0. The derivative of 5x is 5. So this would be 7 into 5x plus 4, the whole raised to 6 into 5. Ultimately, I can multiply 7 and 5, which is 35. So when I ask myself, when I am differentiating this, is it a standard function? Yes. The moment you come to a conclusion that it is a standard function, your chain rule stops existing. Means you have finished your differentiation. Here, is 7x a standard function? Yes. So derivative of 7x would be 7. Is tan x a standard function? Yes. So derivative of tan x would be 6 square x. Is x square plus 5 a standard function? Yes. Derivative of x square plus 5 would be 2x. Let us do it orally. What would derivative of 7x be? 7. What would derivative of 9x plus 4 be? 9. What would derivative of 9x minus 3 be? 9. Now, so what do we learn from this? The moment we see a function which is replica of a standard function is called as a chain rule function. 3 golden steps. Compare the standard function, compare the chain rule function to its standard form and differentiate it in the same manner. Redifferentiate that part, I insist. Redifferentiate that part which is given in place of x. Stop differentiating, step number 3, when you arrive at the standard form, or continue differentiating till you arrive at the standard form. Now the question which arises in the mind of students is, sir, how many times do we need to differentiate? Do I need to extend once or twice or thrice or 4 times? Children, it depends on the question. Let us discuss some questions where we will try to differentiate the functions orally. Then I'll tell you a method which will help us to interpret the functions directly in our competitive exams also. I write sine of 8x plus 3. My question to all of you, is it a trigonometric function? Yes. 8x plus 3 is the angle. What is the power of trigonometric function? 1. Trigonometric function with power 1 is comparable to a standard trigonometric function. So this looks like sine x. What is derivative of sine x? Derivative of sine x would be cos x into d by dx of. Can you tell me what is given in place of x? If the moment I observe what is given in place of x, so I'll have 8x plus 3. When I differentiate 8x plus 3, is it a standard function or a chain rule function? I can interpret the value of derivative of k is 0, 8x will be 8. So they are standard functions. So the derivative ends there itself. So I had to differentiate it twice, continue it twice. Now the easiest way is go from the outermost part to the innermost part. The outermost part was sine, whose derivative is cos. The moment I finish that, just ignore it. Now, what do I see? 8x plus 3. Derivative of 8x plus 3, derivative of 3 would be 0, 8x would be 8. Outermost part to the innermost part. So, here I had to continue my chain rule twice. Let us see the third example. Log of sine of 9x. Now, the outermost part to the innermost part. First, what do I see? Log. So first it's comparable to log. The moment I finish log, what will I see? Sine. So again I will compare it to sine. The moment I finish log and sine, what do I see? 9x. So I'll have to finish with 9x, but 9x is a standard function. So I'm continuing my chain rule thrice. First, what is derivative of log x? So 1 upon x, 1 upon sine 9x into derivative of sine 9x. Here, this is still a chain rule function, so I cannot end my derivative there. into derivative of 9x. So this becomes 1 upon sine 9x into cos 9x into 9. Obviously cos upon sine can be written as cot. So my final result, final answer would be 9 cot 9x. I repeat, outermost part to the innermost part. Log, then sine, then 9x. Done. Let us discuss 3-4 more examples so that we can get well versed with the concept of chain rule. Sine cube log of 5x. Now the moment I see anything with a power, I have to give first preference to the power. Yes, children. We'll be going from the outermost part to the innermost part. The outermost part is n, right? So first it is x raised to n. This is done. What do I see? I see sine, whose derivative will be cos. This is also done. Then I see log, whose derivative is 1 upon x. That is also done. Then I see 5x, whose derivative will be 5. X raised to n, sine, log, 5x. So if I want to interpret the answer, derivative of x raised to n will be n x n minus 1 into derivative of sine of log 5x, but this is still a standard, this is still a composite function, into derivative of log of 5x, this is still a composite function, into derivative of 5x. So the moment you see a question, you should be able to crack how many times I am supposed to redifferentiate. First, x raised to n, then sine, then log, then 5x. This derivative would be cos of log 5x. This derivative would be 1 upon 5x. This derivative would be 5. I repeat once again. Compare the given question, which resembles a standard form, to the standard form and write its derivative accordingly. Step 2. Redifferentiate that part which is given in place of x. Step 3. Continue differentiating till you arrive at the standard form, or stop differentiating when you arrive at the standard form. 3 golden rules. And the fourth important note, go from the outermost part to the innermost part. You will never ever be wrong. Root of, sine of, cos of, log of 4x. Now children, what do I see as the outermost part? Root 1, sine 2, cos 3, log 4, 4x. Done. Because we have reached the innermost part, which is a standard function. What's the derivative of root x? 1 upon 2 root sine of cos of log 4x. What's the derivative of sine? Cos of log 4x. What's the derivative of cos? Minus sine of log 4x. What's the derivative of log 4x? 1 upon 4x. What's the derivative of 4x? Which is 4. Root, sine, cos, log 4x. The last two examples so that we end our discussion of chain rule. Three raised to sine of e raised to x. Yes, the outermost part is a number which is seen. When you see e or a raised to x, the preference is given to the base. So first, a raised to x, a raised to x, log a. Now, sine, so cos, e raised to x. Now, e raised to x. That's it. It's done. It's very, very important, but very, very simple. Thank you, children. Thank you so much.